everybody, and welcome to our video on mechanics of respiration and breathing cycle. So in this video we are going to discuss the exact mechanism of respiration, how we inspire air, how we expire air, or I should say how air gets into our lungs and why it gets into our lungs and how it's expelled from our lung. So starting, we should know why we breathe air, why respiration is going on, and because this is the way by which we can get oxygen to deliver to our tissues and get rid of carbon dioxide produced as a result of the aerobic respiration. So to get oxygen and to remove the carbon dioxide, we have to breathe, and in this video we are going to discuss the mechanism of breathing. So breathing consists of three steps, or three stages. The first stage is rest, which is between expiration and inspiration, and then you have inspiration, when you start to do inspiration, when you start to get air in, and expiration, when air gets out. So starting with rest. What is rest? So let's imagine you inspire air and you release it. After you release the air, this is called the rest stage, or where there is no air moving in and no air is moving out, and your lung volume is the functional residual capacity. So what is the pressure inside the alveoli? It's equal to the atmospheric pressure. There is no air, though there is no air in or no air out. So it's equal to the pulmonary pressure equal to intrapulmonary pressure equal to the atmospheric pressure. What about the interpleural pressure? We explained it in the previous video. If you haven't watched it yet, watch it now. The interpleural pressure is always negative, and we explained the significance of it being negative because it's pulling the lung outward, and we discussed the mechanism of it in the previous video. So this is during rest. Let's say you start to inspire air. Air starts to get into your respiratory system. What are the exact mechanism and what are the specific steps? So the first step is the inspiratory muscles contract, and this is caused the volume of the thorax to increase. So you may wonder, what are the inspiratory muscles? So the most important inspiratory muscle is the diaphragm. It's when it contracts, it's changed from the dome shape to the other shape, where it increases the thorax volume. And as we are increasing the thorax volume, we are pulling I forget the other muscle, which is very, very important. It's the external costal muscle, and these two muscles are explained in our anatomy video. If you haven't watched it, watch it now. These two muscles are responsible for the expansion of the diaphragm outward. The expansion of the thorax outward and increasing the thoracic volume. So as the lung volume increases as a result of the thoracic cages increasing volume, so it's pulling the lung with it, because they are both connected with the pleura, visceral pleura being on lung and parietal pleura being on the thoracic cage. The pressure inside the alveoli decreases, and you may wonder why it decreases, and the answer is simple. This is because of this law, which means that the pressure and volume, when one of them increases, the other will decrease. So when you decrease when you increase the volume inside the lung, the pressure will decrease. So the pressure became less than the atmospheric pressure. So this creates a pressure gradient, where the atmospheric pressure is greater than the pressure inside our lungs. So this is responsible for sucking the air from air into the lungs until the pressure of them equal to each other. And we know that the interpleural pressure becomes more negative, and the increase in negativity is responsible for pulling the lung outward. The more negative, the more pressure exerted on the lung to expand it, and it becomes more negative because due to two reasons. The first reason is that you have the pleura and the parietal pleura and the chest wall are attached to each other. So when you try to expand and you are pulling the parietal pleura outward during inspiration, and you have the lung is trying to pull inward due to its elastic connective tissue, this creates a negative pressure inside the pleural cavity, and I have another video on it. You can watch it to understand why it becomes more negative. So the lung volume increases by the tidal volume. The tidal volume is the air that gets into your lungs during inspiration. So at the peak of your inspiration, the lung volume is equal to the functional residual capacity plus the tidal volume you inspired. And here is the diagram that shows you the details in steps. First, you have the contraction of the diaphragm, relaxation of the muscles responsible for expiration, and contraction of chest elevating muscles. This results in what? This results in the chest wall being expanded outward. As we see, muscles are pulling from here and from here, and this increases the vertical diameter of the thorax and the anterior, posterior, and transverse dimensions of the thorax. What happens is that because of this you decrease the interpleural pressure, and because it's attached, as I explained in the previous slide, because the cohesion of the visceral and parietal pleura and the compliance of the thorax and the lung, one of them is pulling outward and the other is pulling inward. This creates a negative pressure inside more negative pressure inside the pleural cavity, and this is responsible for expansion of the lung. And when you expand the lung, you decrease the pressure. This is because P1 equal P2 V2, as I explained in the previous slide. And this establishes a pressure gradient, so the air can move from outward an area of high pressure to inward of an area of low pressure, and this is causes inspiration. As you see, thoracic cavity increases in size during inspiration. Moving on, let's study expiration. What is expiration? It's when you release the air inside your lungs outward to the atmospheric pressure. So you have to decrease the volume inside the lung, so that the pressure increases and becomes more than the pressure inside the atmospheric pressure. So air moves from lung to atmospheric pressure, or I should say to the atmosphere, from area of high pressure in the lung to area of low pressure in the atmosphere. So the diaphragm begins to relax, and when it relaxes, it decreases the thorax volume. And when you decrease the thorax volume, I'm sorry, I again forgot the muscles that are responsible for the expiration, which are the internal costal muscles. When they also contract, they pull the chest wall inward, and these two cause the lung to deflate because the interpleural pressure becomes less negative. It becomes less negative, so the lung begins to deflate, and when they deflate, this decrease in the volume causes increase in pressure, so the alveolar pressure becomes more positive and air in the lung is expelled out to the area of low pressure, which is the atmosphere. And here is a diagram similar to the previous one explaining. We have relaxation of inspiratory muscles, contraction of expiratory muscles. This causes decrease inside of thorax, and this increases the interpleural pressure. Together with the elastic recoil of lung tissue, its ability to recoil back to the elastic connective tissue, this decreases the size of the lung and again increases the alveolar pressure. This causes pressure gradient for the air to move from inward to outward, and this causes expiration. And here is another diagram that show you. Here you have you are inspiring, you are taking air in, so you are increasing the transpulmonary pressure on the lung, so there is more force pulling this way, and when there is more force the pressure here decreases, so air gets in, and when air gets in it expands. When air gets in it expands, and during expiration the reverse happens. The interpleural pressure becomes less negative and this pulls inward, so increases the pressure here, so becomes more than the atmospheric pressure, so air gets from here to here, and this causes expiration. And this concludes our video on mechanism of breathing.